Hey everyone, so today I'm going to be telling you more about radiation, more specifically background radiation and some of the risks of the radiation. So we know from last video that some atoms happen to be radioactive, so their nucleus are unstable and they try to become stable by decaying, meaning that they emit a particle in energetic radiation, and this is a random event, so it's called radioactive decay and we cannot predict exactly when it's going to happen, okay? So we know that stuff. Now, let's think about the atoms, really. So the atom looks more, to be honest, is more like this than what you see normally in school. So it's more or less like this, okay? But none of these are actually good picture or drawing of how an atom should look like. But you have the nucleus at the center, and the nucleus is made of protons and neutrons, okay? And then you have the electrons going around in the atom. Protons and neutrons, so neutrons have no charge, protons have a positive charge, and electrons have a negative charge. Actually, I think last video I said something like an atom should have the same number of protons and neutrons. I wanted to say protons and electrons, because an atom will have the same number of protons and electrons, meaning that the negative charges are the same as the positive charges, and therefore is a neutral atom, so with no charge. The number of neutrons can change, and this is why some radioactive substances have an unstable nucleus. I even put a link for an A-level lesson where you understand a little bit more what makes an atom stable or unstable, okay? So, just so you know as well, so this is, so far from this video, this is the best picture really, how it should look like. I just want you as well to have an idea of the size of the atom, because what happens is, the atom is actually mostly empty space. If you imagine a full stadium, okay, and this is the whole atom, the nucleus would be a small beam at the center of the stadium, okay? So this is for you to have an idea of the relative size, which is going to help you in a lesson where I'm going to tell you about the discovery of the nucleus, okay? So, you guys know that we have alpha, beta, and gamma radiation, and these are emitted by specific isotopes, which again, if you don't know what an isotope is, hold tight because I'm going to have a video on isotopes, and they emit radiation. Now, there's also radiation that is naturally around us, and it's called background radiation, okay? And it can come from different sources. It could be from rocks and soil, cosmic rays, some foods, hospital equipment, and building materials, okay? So any of these can actually emit radiation that is going to get to us. So we are exposed to this radiation all the time, so it's called background radiation, okay? So, trying to move the slide, contributions of different sources of background radiation. So, we have natural 85% and artificial 15%. So, that means that most radiation that we have around us, that is the background radiation, comes out naturally. So, again, the cosmic rays, food and drink, random gas from the ground, so some you know, from some rocks, buildings in the ground. And then 15% is artificial sources, where it's going to be 14% out of 15 is medical uses, and 1% is from nuclear products, discharges, nuclear fallout, okay? So this is for you to have an idea of the percentage that we get of background radiation, so radiation that is always there for us, okay? I have a definition for you to write down if you want. So, in terms of natural, random gas is 50%, okay, more on random gas in a second. Buildings and ground, which is gamma rays, 14%, food and drink, 11.5%, and cosmic rays, 10%, okay? So, what is the actual definition of background radiation? Is radiation that is constantly present in the environment and is emitted from a variety of natural and artificial sources. When I teach this, I give them the example when in lessons I say there is some background noise, meaning that someone out there and I don't quite know where it is, or I cannot point the source is someone is talking and I can hear it, and that talking is always present, is always happening. So the same with background radiation, okay? So with background radiation is always there, okay, and is but you may not just say it's coming from here because I can see it, okay? So it's the same. Also, a quite interesting video, which I'm going to put in the description. This is this video by Veritasium, the most radioactive places on Earth. This is a very interesting video for you to watch. It's a little bit long, but give it a go, okay? So, let's just do an exercise, a couple of exercises on background radiation. Pause the video if you want to try them first and then see if it's right. Otherwise, here are the answers. A radioactive substance contains an unstable nucleus that becomes stable by emitting radiation. There are three main types of radiation: alpha, beta, and gamma. Radioactive decay is a random event. We cannot predict or influence when it will happen. Background radiation is from radioactive substances in the environment or from space or from devices such as X-rays machines. So this you should all know and should explain in detail, okay? Another quick exercise, again, pause it if you want to try it yourselves and then check if the answers are right. So I want to know if these 9 different sentences are true or false and correct the false ones. So, we are being exposed to radiation all the time, even now while doing this quiz. That is true. It's background radiation. Our body can sense exposure to radiation. No, you cannot feel it coming into your bodies, okay? You don't feel it right now as you're watching this video. It is possible to reduce the risk from random gas in affected homes. So random gas is alpha radiation that you may get in your homes because of the rocks underground, okay? And you can actually insulate your home, test your home for random gas and insulate your home, or try to find some alternatives to, even if the random gas gets into your house, to get it out. Different people may be exposed to different amounts of radiation depending on their job. That is true. People that work in hospitals, or astronauts, or pilots, or people that travel a lot, they are exposed to more radiation than those that don't, okay? Even in hospitals, they should wear a badge. If you are a person that is going to be quite exposed to radiation, they have a badge, and then if the badge shows a certain number, meaning that they were exposed to a certain level of radiation, they actually need to get out and be off for a while until the radiation dose is not as high. At least this happened some years ago, but I believe it's still happening. The lower the radiation dose, the lower the risk. Now, this is true, but you need to be careful with that, because sometimes it has to do with the radiation that you get, okay? Ionizing radiation can cause heart disease or even kill cells. Now, ionizing radiation can kill cells, but does not cause heart disease, so that's why it's half true, so it's false. Radioactive materials can be used to diagnose medical problems. It is true, and you will see how, okay? Not in this video, maybe. Hospitals take precautions to make sure that radioactive materials never get inside a patient's body. Now, the problem with this sentence is a never. We want to avoid the radiation exposure, but if you need to take an X-ray, then there you go, you need to take an X-ray. So they take precaution to avoid or minimize the amount of radiation, but sometimes it needs to get to your body for medical uses. Finally, there are 2 main types of ionizing radiation, alpha and gamma. Of course, that's false. There is beta as well. Okay, so this is it in terms of exercises. Now, this so much is just more for you to understand what is going on. There is this gas called random gas, okay? Now, people didn't quite know about it, and over 400 years ago, there was a high death rate by lung cancer between German silver miners, and people were like, okay, this cannot be a coincidence. What is happening in here? Now, random gas, which is, as the name says, a gas, is a hazard, so it's produced naturally in some rocks. It is radioactive, and it produces ionizing radiation. It gives off alpha radiation, okay? So, people were actually trying to figure out, okay, alpha radiation, lung cancer. Now, if you saw my previous video, you know that alpha radiation doesn't go through your skin, gets easily absorbed by a few centimeters of air or paper, but somehow these people were dying by lung cancer. Alpha radiation, we also know, is highly ionizing. So if you're working in a mine, you are so close to where the random gas is, you are actually breathing in. And what happens when you breathe it in? It goes to your lungs. And lungs are quite a sensitive organ. So, you know, this is why I said it's not just to do with the radiation dose, but where it's going as well. So this was why so many people were dying by lung cancer because of random gas. So what is the health effects that radiation on living cells has? The cell is not damaged as the radiation passes through it, but or the cell is damaged but repairs itself, or it could happen that the cell is killed. It could happen that the cell's DNA is damaged and the cell develops out of control, where you can bring out a cancer. More on that in a video. The radiation may change a gene if it is a sex cell and cause a mutation. Oh, sorry, I thought there was another one. So all of these things can happen, okay? So it could be that nothing happens to you, okay? But it could happen that you get the cell gets killed, or is a bad cell, the DNA is changed, and then because cells grow by cloning themselves, you get a bad cell cloning into another bad cell, and so on and so on and so on, which is a cancer, and they are going out of control, which is another issue with the cancer. Or radiation can cause a mutation, okay? So this is all you need to know in terms of radiation, what it does, right? But why were the miners the main victims? I kind of told you that already. So you are getting the miners to breathe in the random in. So the radiation was going inside their lungs, and the lung tissue is easily damaged, okay? And also, we know that that was happening because random builds up in closed spaces, such as in mines, okay? In the atmosphere, gets spread out because the rocks keep producing the gas, and the gas cannot escape in the mines, but it can escape in the atmosphere. So this is why certain jobs may cause you to be more or less exposed to radiation, and this could or not have an effect in your body, depending on two things. The radiation dose that you get depends on the amount of radiation and the concentration of that radiation, and the type of tissue that is exposed, okay? So how do I measure radiation? And that has to do with that video as well. Radiation is measured in sieverts, okay? Actually millisieverts, okay? And the UK average annual dose is 2.6 millisieverts. So we all, by average, 1 year, we get 2.6 millisieverts just by moving around. Besides of mines, which other places and jobs may give you a higher dose of radiation and therefore get you more at risk? Anything that has to do with high altitudes, okay? Some houses built over the rocks like granite. And, oh, sorry, I again thought there was another one. We're going almost to the end of the video, so maybe I was just rushing through. So, higher altitudes, pilots, as I told you. Houses, they may release random gas that gets trapped inside the house. People that work in a building, and again in the mines, they should be wearing masks. So, when you are exposed to radiation, there is a difference. You can either get contaminated by the radiation or just irradiation, okay? So radiation, irradiation, okay? So what is the difference? And again, pause if you want to try it yourself. Irradiation is when the radiation is outside the body. Contamination is when the radiation enters the body or gets in the skins or clothes. So you can have irradiation but not get contaminated, okay? If you get contaminated, then the radiation either is in your body or it got into your skin or clothes. Therefore, random irradiation presents a very low risk because it's outside the body and it's alpha radiation, so it's unlikely to get in. But random contamination presents a very high risk because that means that you have the most ionizing type of radiation inside your body, okay? So, random irradiation presents a very low risk because alpha radiation only travels a few centimeters in air, doesn't travel through skin, and is easily absorbed, okay? So, to summarize everything, so ionization, which can produce a cancer, is when you have a particle with a random gas, is a alpha particle that kicks out of an electron If that happens, the number of electrons and number of protons is not the same anymore, and you get a positive ion. An ion is an atom with a charge. So alpha radiation kicks off an electron. I have now more protons than electrons, so overall I have a positive charge, I have an ion, okay? So, summarizing, what are the dangers inside or outside the body, or which radiations or type of radiations are the most dangerous for you? Pause it now, otherwise I'm going to go and give you the answers right now, okay? So, when sources of radiation are outside the body, beta and gamma radiation are the most dangerous for you to have them, because they may reach the cells of organs and they may be absorbed by them, okay? So you could have irradiation and contamination because they can get inside your body. Alpha radiation is the least dangerous because it's unlikely to reach the living cells, so you just have the irradiation. However, inside the body, like the miners that were actually so close to the alpha radiation, they were breathing it in. So when the sources of radiation are inside the body, alpha radiation is the most dangerous because it is the most ionizing. Now you are contaminated, okay? Beta and gamma are less dangerous because the cells are less likely to absorb the radiation because they do not have enough energy, or because the energy is not going to be so much that can kill or mutate your cells or cause a change in your DNA. So I hope it made sense in terms of background radiation and some risks. I also gave you an extra of random gas, which is not coming into exams, but sometimes they can make it as these questions on how science works, or where they say this is this type of radiation, which conclusions could you take about it or around it. So I decided to put it as well because it can only help. I mean, it cannot do any harm. So I hope it made sense. Up to my next video. Be happy and healthy. Bye!